Hi guys, it's going to be super quick notes today because I am going to do the experiments off camera and just give you the results. Okay, experimental versus theoretical. The ratio of the number of times an event occurs to the total number of trials. Experimental probability answers the questions, what actually happened? That's what I'm going to do off camera. Theoretical is the probability of an event happening based on all possible outcomes. Okay, so for example, what's the theoretical probability of a spinner landing on a circle? Well, you take your total 1, 2, 3, 4, 5, 6, 7. Seven's the number on the bottom. How many circles do we have? One. So 1/7. What's the theoretical probability of a spinner landing on a heart? Again, there's 2 hearts, so it's 2 out of 7. What's the theoretical probability of a spinner the complement, not landing on a circle or diamond? Well, that would be 4 out of 7. So now what I'm going to do is I'm going to actually do the experiment and I will tell you the results. Okay, I'm back. So I spun the spinner 14 times, as it says right here. And these are the results that I got. So the question is, are there any results in which the theoretical and experiment were the same? And I can say yes. On the triangle, they were the exact same. So yes, on the triangle, they were the same. Were the same. Okay. So that's what you're kind of looking at. Theoretical versus experimental. Theoretical is what could theoretically happen. Experimental is, well, what actually happened. Okay. So let's go to the backside. Then we have what's called relative frequency. Relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. In tomorrow's lesson, we're going to talk a lot about making predictions. So it can make predictions. As the number of trials increases, the relative frequency of an event will approach the theoretical probability. So the more that you do it, the theoretical probability, the more that you do it, the more chances you are to actually get the right number. Okay. So the spinner below is spun 50 times, and the results are going to be shown in the table. I'm going to do that for you off screen. Complete the experiment by using a paper clip and pencil to spin the spinner 100 times. So here's what happened when they did it 50 times. So the relative frequency when they did it 50 times, so let's look at this right here, was 12 over 50, okay, which comes down to 6 over 25, okay? And then if I go on down, I'm just going to reduce it for you already so we're not wasting time. This would be 4 over 25. This would be 13 over 50. This is 1 over 50. Okay. And 7 over 50. If you don't understand how I'm getting these numbers, come and see me. All I did was take the number over the number it actually happened over the total spins. And then I reduced it when possible to reduce. Now I'm going to do it 100 times off screen. Okay, so I spun the spinner 100 times. Oh my gosh, it took forever. See, I like taped it on there and then I did my little tally marks. Anyways, you would expect, so the theoretical would be 20 over 100, which would equal 1/5, right? 1 out of 5. Well, here we got 19 out of 100. We got 25 out of 100, which is 1/4. We got 18 out of 100, which is, I don't know, 9/25. 9/25. 19 out of 100, and 19 out of 100. So again, we would have expected to get 20 out of 100. We got pretty close. We got pretty close. So the big thing that I noticed when I did it is the theoretical of landing on each number is 20%. What did you notice? And what patterns did you discover? So the theoretical would be 20%. And what percent was each of these? So 19 divided by 100 is 19%. So this is 19%, 19%, 19%. This happened to be 25%. And then 18 divided by 100 is 18%. So we got pretty close, guys. Pretty close. What patterns did you discover? We got pretty close. Okay. How can you describe the likelihood of spinning a 5 compared to spinning a 2? Well, the likelihood they're equally likely. Equally likely. And Kane is going to spin the same number 1,000 times. How can you expect the frequency to change? I think it'll be closer. It should be closer to the theoretical. Theoretical. Okay. Abe has, so again, this is just Abe has 5 bills, 3 bills, and 20 bills in his wallet. He reaches in randomly. What's the likelihood of selecting a 20 compared to a 5? He's half as likely. Half as likely. What event is less likely to occur than getting a 10? So we have 3 10s and 2 20s. So getting a 20. A 20. And then what is the likelihood of Abe selecting a 5 or 20 bill as compared to a 10? So that would be 2 times as likely. Okay, there you go. There's your notes.